Okay, so today what we're doing is we're just going to be continuing with looking at like what are the different topics in research methods that are important. So when we're conducting like a research study or an experiment, basically these are the topics that are really important for us to take into consideration. So today's topic that we're going to go through, or the first topic we're going through today, is called unwanted variables. Now, last week, you might remember we learned about two types of variables, which were quite important for every experiment, and those were the independent and the dependent variables. So the independent variable is like your cause, and the dependent variable is like your effect. And we said that all experiments operate on a cause-effect relationship. Yeah, looking at the cause and then looking at some kind of effect or some kind of impact that comes out of that cause. So remember, we looked at a few different examples last time. We looked at like, red cordial influencing hyperactivity in children. We looked at sleep deprivation influencing driving ability in adults. We looked at learning memory tips as influencing study skills or memory in VCE students. So obviously you can make up any example, any type of experiment, but that experiment will always have some kind of a cause and some kind of effect, okay? Now, unwanted variables are variables other than the cause and other than the effect. They're variables other than the IV and other than the DV. We call them unwanted because we don't want these variables to be in our study, because what they do is they make it confusing for us to conclude whether the IV definitely or certainly caused the change in the DV. And I'll give you an example with reference to that hyperactivity scenario we looked at last time. So if I'm a researcher and I'm investigating the impact of red cordial consumption on hyperactivity in children, and then I've chosen my participants and I've chosen a bunch of kids, but one of these kids is already naturally hyperactive to begin with. They don't even need the red cordial. They're always, as soon as they wake up at 6 a.m. in the morning, they're already like jumping off the walls. They're already seriously hyperactive. Their hyperactivity or their natural kind of ability to be hyperactive could act as an unwanted variable for me, because then it's difficult for me to determine at the end of the study, okay, was it the red cordial I gave them, or was it their natural hyperactivity that caused them to be so hyperactive? Okay, so that's why we say that these variables, which we call as extraneous variables and potential confounding variables, are actually unwanted. Okay, we don't want them because they make it difficult for us to determine with certainty whether it was the independent variable, that is whether it was the IV, or whether it was some other cause or some other factor that actually influenced the DV or that actually influenced that behavior. I'll give you another example to make it more clear. So if I am assessing, if I'm basically doing a study investigating the impact of making colored notes, so making beautiful colored notes with highlights and everything, and the impact of doing that on a SAC score, okay? The impact of making detailed, extensive, and beautiful looking study notes on your actual SAC score. Well, I could ask all of you to make beautiful study notes that look so pretty, that are nice and organized, that look like something you find on, Instagram or Pinterest, but that could all be invalid, or that could not be helpful if, let's say, some of you are a little bit more hardworking than others, or some of you have a better natural memory ability than others, or some of you do more practice questions than others, okay? All of these are unwanted variables because they make it difficult for me to determine with certainty, okay, was it the colored, beautiful study notes that this girl made, or was it her actual natural memory ability that made her get the high SAC score in the end, okay? So obviously, an unwanted variable is any variable other than the IV. If your IV is making beautiful colored study notes, that's your IV. Anything other than that, which goes on to affect your SAC score, is what we call as a potential confounding variable or an extraneous variable. So just differentiating between these two now, extraneous variables are any environmental variables. So remember, E for extraneous, E for environmental. They happen, they usually are easy to identify. So if I'm going to get you guys to do a SAC, or if I'm going to get you guys to do a memory test, I'm going to be looking at, okay, what are the variables that could potentially affect your performance? If I take you to a room and it's like really dark and the lights don't work properly, I'm not going to do the test there because that's going to affect your ability to maybe read the questions. If I take you to a class and there's a lot of construction happening on the roof or a lot of construction happening outside and a lot of noise is coming out of that, I'm not going to make you do it there because that noise might affect your ability to concentrate. Okay, if I'm going to take you to a room to do that test or that memory test or SAC, and it's really cold or it's really hot, that might affect, again, your ability to concentrate and sit in one place and do the SAC to the best of your ability. Okay, so extraneous variables are almost always environmental variables. They can still affect the DV because they specifically affect your performance on a specific variable, okay? Potential confounding variables are a little bit more different. Potential confounding variables are a lot harder to identify. They're not something we can just identify and try to get rid of at the beginning of the study. And potential confounding variables are more likely to actually go on to confound or affect the DV in an unwanted way. What we mean by the word confound is that we mean that something has become confusing, okay? It's become confusing for us to now conclude whether the IV had the result or whether the unwanted variable or the potential confounding variable led to that impact in the results. So extraneous variables are easier to identify at the start of the study, and we can get rid of them in some way, or we can control for them by moving to a room with more light, by reducing the noise, by making it a more temperate temperature or more ideal temperature. Potential confounding variables are a little bit more harder to identify. So if I, for example, with the hyperactivity study, if I've like sampled a bunch of kids, I might not know each of their personal characteristics. I might not know that each of them is potentially more hyperactive on a natural day than the other, okay? Because I don't know these kids personally. And so these are the variables, the potential confounding variables are the ones that are more likely to slip through, okay? Driving ability in a driving related study. So if I'm measuring the ability of, investigation of does sleep deprivation impact a person's driving ability? Well, generally we know that yes, if you're sleep deprived, you won't drive as well. You might make more mistakes. But let's say I take 10 people and some of those people are really like good at pulling all-nighters. They can stay up and they don't get affected that much. Where some of those people are strictly like they've got 10 hours sleep each night, like they have to sleep properly. The people who are more likely to pull all-nighters every day might be less affected by sleep deprivation and thus less likely to make mistakes in driving ability as compared to the people who sleep 10 hours per night. And so what you can see here is that obviously there is going to be an unwanted variable there in the sense that we are giving some of these participants an unfair advantage and some of the participants are having an unfair disadvantage because of their individual differences in terms of their sleep patterns. Okay, so that's basically our unwanted variables that we're looking at. These are variables we always need to try to control. I've already talked about this slide in the previous one, just basically the difference between the two. So we use the triple E memory tip here. E for extraneous variables, E for the fact that they usually refer to environmental variables like light, noise, and sound, and E for the fact that they're usually eradicated or eliminated at the beginning of the study. And a lot of extraneous variables don't go on to have a major impact on your results, okay? Because you do identify them early in the study. They're pretty obvious and they're pretty easy to control. Obviously, like I said before, potential confounding variables are not usually identified early in the study. They're harder to make out or they're harder to identify. And for that reason, they do go on to confound or affect the DV in an unwanted way. So obviously, there are a lot of different variables we can look at, but according to our study design, we only need to know about the following potential confounding variables. So individual participant differences, that's referring to like individual differences in participants' personalities or characteristics. Like how I was telling you guys, some children may be more naturally hyperactive than others. Okay, that's an individual participant difference because it depends on the individual. Order effects are something that we won't cover in a lot of depth right now because we do have to first cover the designs to go through this one. Placebo effect is basically looking at participants' expectations. So if participants, if we're doing a study investigating the impact of Panadol on pain relief, if the participants know that they're being given Panadol, how will they act differently? Will they act in a way that, will they act in line with certain expectations that, hey, I'm being given the Panadol, so I should act like I'm feeling better. Experimenter effect is when the experimenter has expectations for the participants, which we're going to go through soon. And non-standardized instructions and procedures is when you have two groups in a study, which we usually do. We have got an experimental group and a control group, and the experimenter might give out the instructions and procedures maybe in a different way to both groups. And sometimes if one group gets more clearer instructions or gets delivered those instructions in a nicer tone, that group might perform better because the experimenter treated them in a nicer and better way. We also need to know ways of minimizing and controlling for extraneous and potential confounding variables. So these are the different ways in which we try to do that. So we'll come to this eventually once we go through the others. So the first thing we're looking at, which is a potential confounding variable, which can actually make it difficult for us to determine whether the IV caused the DV or whether it was the individual participant difference, is basically our individual participant differences. Now, individual participant differences refer to participant variables that make one participant different from another and thus affect the individual performance. Now, if all your participants have got different characteristics, the problem with that is that they bring something different to the table. And so when they're actually participating in your study, their individual characteristics might take over the influence or the effect of the actual IV that they're being exposed to. Okay, so if you've got a study where obviously, we're testing people's communication abilities and the researcher is trying to get something out of everyone in terms of ideas, maybe one person is super enthusiastic, like this guy in the picture here. One person might be a little bit more anxious and shy. One person might be a little bit daydreaming, like just staring into space. Maybe another person is like super annoyed that they have to be in the study. They might be giving a little bit of attitude there. Okay, so obviously, because each participant is different, the actual results you get at the end will be quite different as well. And the problem with that is when participants are completely different from each other, or they're almost like polar opposites of each other, that can actually lead to a lot of individual participant differences kicking in, okay, which make it difficult for us to determine, was it the IV or was it their actual individual difference that led to the actual results? Now, individual participant differences are a problem because they can either give participants an added advantage or a disadvantage. And so thus the individual participant difference can either increase the person's performance or decrease their performance. Okay, so obviously, how do we control for or minimize the effect of individual participant differences? Now, the best thing we can do is that rather than getting different people to go through both the experimental condition and control condition, you get the same person. So you get, if this guy's name is Stephen, you get Stephen to go through the experimental condition, and then you get that same guy, Stephen, to then go through the control condition. So you're having more participants that are exactly the same, okay? Because obviously if it's the same person going through both conditions, there won't be room for individual participant differences, okay? Because it's the same participant that we're using twice. Having very large sample sizes can also balance out individual differences. And when we say very large, we're talking about in the hundreds or thousands, okay? So obviously the more larger your sample is, the individual differences kind of balance out, okay? Also another thing that you can do, we haven't gone through designs yet, but another type of design that's really good is called the match participants design, and that involves matching participants on a certain characteristic. So, if we're matching them in terms of height, we find as many participants as we can that are exactly 6 foot in height. If we're measuring them in terms of intelligence, we find as many participants as we can that have an IQ between 130 to 140. If we're measuring physical fitness level, we find as many participants as we can who scored similar scores on the BEEP test. Okay, so obviously that's what a match participants design is. It's good because we are reducing the individual participant differences and we're making the participants as similar as possible. Okay, the next type of potential confounding variable we go through, which I just lightly talked about before, is the use of non-standardized instructions and procedures. So like I said before, you can have the same researcher, or you might have two different researchers. And if these researchers are not delivering the instructions or procedures in the exact same identical way, if one researcher is being super organized, super formal, writing things down, delivering the instructions very clearly to the participants and making sure everything is understood, whereas researcher number 2 doesn't really care, and he's kind of like, yeah, whatever, and he's kind of like, making paper planes out of the instruction sheets and everything, well, then the participants are going to get a different impression from both of them, okay? And maybe the participants who were delivered instructions by this guy might be likely to take the experiment a little bit more seriously, whereas people who were delivered participants from this guy, sorry, people who were delivered instructions by this guy might not take the experiment as seriously, because this guy himself delivered the instructions in a very ambiguous way without going into detail and without taking it seriously. Okay, so that's basically non-standardized instructions and procedures. So what we need to do is we need to make sure that both of our researchers, if we've got two researchers in a study that are going to be delivering the instructions for how the study is going to run, we need to ensure that both of these researchers are actually delivering the instructions in the exact same way, same manner, same word, same tone, same order of presentation, same appearance, all that kind of stuff. Okay, so obviously one way that we can promote them to do this in the same way is to give them a script and to just make them read from that script so that they're not adding anything extra or not removing anything there. So that's what we call the use of non-standardized instructions and procedures. Non-standardized means that there's no standard, okay, no standard. So they're doing it differently. We need to make sure in a proper study that there is a standard for how these researchers are going to deliver their instructions to participants. Order effects we're not going to go through right now because it's not going to make a lot of sense. I will come back to this though, because we have to cover the designs first in order to then cover the order effects, but we will come back to this eventually. So I'm just going to move on to the next one. The next one is called the experimenter effect. So experimenter effect is when the researcher places expectations on the participants. So sometimes they might imply how they should respond to the treatment or study. So if I'm doing an experiment on the effect of green tea consumption on weight loss, and I tell my participants, when I'm giving my participants the green tea, when I'm giving my experimental group participants the green tea, I'm like, here's the green tea. You know what? It actually helps you to lose weight. In fact, my cousin who drank this for 3 months lost like 5 kilos. My participants are going to be like, oh, wow, if her cousin lost 5 kilos from this, then I should surely lose some as well. And what you're doing then as an experimenter is you are you're preempting the participants to behave in a certain way. And you're placing your expectations of how they should behave on that specific group of people that you're studying, on that experimental group. One reason why the experimenter effect is bad for our experiment and why it is a potential confounding variable is it then becomes difficult for us to determine whether the participant's reaction to the green tea was because of a natural effect of the green tea or a natural effect of the IV there, or whether it was because the doctor or the experimenter has told them how they should expect to behave or what they should expect to see or what they should expect in terms of a reaction or a response, okay? So obviously the experimenter effect is problematic, and whenever the researcher is giving an IV to the participants, they should never tell the participants how they can expect to behave. That's never how it should be. The doctor should just give them the green tea and just walk the other way. He should never ever, the experimenter or doctor should never ever tell the participants how they will expect to behave or how they might be expected to respond. Now, how we control for the experimenter effect is we can use something called a double-blind procedure. Double-blind procedure is, as you can see in this picture here, the patients are blind to who is getting the experimental treatment. So each of these patients, they don't know, are they getting the IV or are they getting the placebo? Are they getting the actual active experimental treatment or the green tea? Or are they just getting a yellow color liquid that sounds bad. Are they just getting like a yellow color liquid that doesn't actually have any green tea component, but it looks like green tea, but it's actually just some inactive substance, okay? That's a placebo. So each of these participants don't know what treatment they're getting, and the doctor doesn't know which group is getting them either, okay? So the doctor or the experimenter is blind to who's getting the experimental treatment. He doesn't know who he's giving the green tea to, so how will he know who to put his expectations onto? And the same thing the participants don't know as well. So the double-blind procedure actually addresses both the experimenter effect and another effect which we're going to go through next, which is called the placebo effect. Okay, so the double-blind procedure is a very good procedure we can use to control for both the experimenter effect and the placebo effect as well. So again, the experimenter effect is all about the impact of expectations and how expectations can have an unwanted effect on the DV or on the results. The placebo effect is basically looking at, again, expectations, but now the expectations don't come from the researcher, or from the experimenter, they come from the participants themselves. So sometimes the researcher will just give the participants the green tea and then walk the other way, but the participants might be like, oh wow, isn't this green tea? I've read a lot of, I remember reading a lot of magazine articles about how green tea might promote weight loss. Maybe the experimenter wants us or expects us to lose weight from this. Okay, I'm going to make sure that I can tell the experimenter that I did lose weight from taking this green tea. So what the participants are essentially doing in the placebo effect is they're presuming that the experimenter expects them to behave in a certain way. And so they're presuming, because they're receiving the IV, because they're receiving that green tea, that they should respond or behave in a certain way to match the expectations or to impress the experimenter or researcher, and to make sure that they do match their expectations. Okay, even though in this placebo effect, the experimenter themselves is not placing any expectations on the participants are doing that themselves. Now, how do we control for or minimize the effect? So we know that a placebo is simply an inactive treatment. Okay, a placebo is a fake treatment. So if we're studying the impact of Panadol on pain relief, you might give the experimental group Panadol, like an actual Panadol tablet, and they take the tablet, whereas the control group receive a placebo. Placebo means they'll get a white tablet which looks exactly like Panadol, but it doesn't have any of the active ingredient of Panadol in it. It's got 0 paracetamol in it. It doesn't actually have any active substance. It's just a white tablet, which is just like maybe a sugar pill. Doesn't taste like anything. It doesn't have any active substance in it. Okay, now the single blind procedure is used to eliminate the placebo effect. Now this is when the participants don't know which group they are getting allocated to. They don't know whether they're in the experimental group or whether they're in the control group. And for that reason, they also don't know whether they are receiving the actual Panadol tablet or the actual experimental treatment, or whether they are simply receiving the placebo, which is the fake treatment, or the treatment that looks like a Panadol tablet but doesn't have any paracetamol in it. When the participants don't know which of the two they are receiving, whether they're receiving the real treatment, the real IV, or just the placebo, which is the control treatment, they will not behave in a certain way. Okay, they won't change their behavior because, again, they don't know which type of treatment they are receiving in this case. So single blind procedure is when the participants, it's only the participants, it's only a single group here, only the participants who are blind to whether they are receiving the experimental or control treatment. Okay, and so essentially when you don't know whether you're receiving the real IV or not, you're not going to change your behavior in order to match that particular expectation. Okay, so that's what the placebo effect is about. And placebo effect is something we can really, we don't have to run an experiment to observe how it works. We can even just run, we can even just, like, if you give someone like, let's say you give someone like decaf coffee, doesn't have any caffeine in it, but after they drink it, they might be like, oh, that really hit the spot. That made me really feel better. I feel like I can concentrate better now. Even though the coffee you gave them has 0% caffeine in it because it's decaf. Okay. In the same way, if you serve someone like a non-alcoholic beer, they might start to act drunk. Okay. They might start to act like they're like super drunk. They might start to act like they're actually intoxicated when actually the beer you gave them was 0% alcohol. So again, placebo effect is talking about the way that our expectations of how we should behave can influence our actual natural demonstration of that behavior. Okay, now we're just going to go through the sampling procedures. Okay, sampling procedures is how we actually sample participants to be in our study. So the first type of sampling we can use, or the first sampling is basically about selecting participants for our study. So what are the different ways in which we can select participants for our study? The first one is called random sampling. Random sampling is a really simple process. It's like if I come into psych class and I'm like, okay guys, I'm going to be doing a study. I'm going to be doing a study on the impact of memory strategies on SAC performance. And I take all of your names from the synergetic or from the role, and then I put them into a box, and then I draw out the first 10 names. And the first 10 names that I take out of that box, those are the people that are going to be in my study. Okay, random sampling is simply that. Random sampling is the procedure that ensures that every member of that population or every person has an equal chance of being selected for the sample, because you are sampling at random. You're doing random selection there in the sense that everyone does have an equal chance. No one is more likely to be in the sample than someone else. Now, obviously, when you've got small amounts of people, like 20 or 30 or 40 people, we can easily put their names in a box and take them out. But when we've got more bigger groups of people, like the population of Australia, the population of Victoria, or you've got hundreds of people, it's a lot easier to just run the numbers or run the names through a computer program, which will then randomly generate a list of people for you. Okay, random sampling is a really good sampling procedure, because it does allow us to generalize results back to the population. Now, you won't really understand what we mean by generalized results right now, but generalized result is very important for us. In fact, whenever a researcher does a research study or experiment, the main goal that they have in mind is they should be able to generalize those results back to the population. Okay, again, it's not easy to generalize results, and we will be talking a little bit more about this in the coming weeks, probably when we get back to school. But like when we use random sampling, it's one step forward in terms of us being able to generalize results. One of the disadvantages of random sampling, though, is that random sampling is random, okay? And there is a lot of room for individual difference. And this can obviously act as a potential confounding variable for some studies. So like I said, if I draw 10 of your names from a box, obviously all of you, even though you all do psych, you're all different people, yeah? There's not much similarity between you. And so those 10 names that I draw, yes, they will be drawn at random. Yes, no one had an unfair advantage or disadvantage because everyone did have an equal chance of being selected. But still, there will be a lot of individual differences between those 10 participants. I haven't tried to match you guys in terms of similarities. I haven't tried to ensure that everyone is as similar as possible. Okay, it's just random sampling then. So random sampling ensures that everyone has an equal chance of being selected for a sample, because we are obviously selecting using a randomized technique. Okay, we're selecting at random. We're not giving someone an unfair advantage. We're not selecting participants based on bias or based on certain abilities or skills. Stratified sampling is, again, another type of sampling that we might use. We tend to use stratified sampling a little bit more if we're studying like different levels of people. If we're studying, for example, high school students, we might divide our population into layers. So one layer is, and you might remember the word strata from like humanities when you learnt about like the earth and the earth's core and the different layers of the earth. Okay, strata just basically means layers. So in stratified sampling, what we do is we take a population like high school students and we divide them into layers. So what that might look like is one layer is year 7, one is year 8, one is year 9, year 10, year 11, and year 12. And then from each of those layers that we've divided our population into, we choose a few students from each of those layers according to our research need. So if I'm doing a study on the impact of, the impact of, the impact of caffeine consumption on mathematical performance or mathematical ability, I might choose like the best math students from year 7, the best math students from year 8, the best math students from year 9 up to year 12, okay? Or if I'm choosing the impact of, high literacy skills on essay writing, I might then pick the best English students from year 7, the best from year 8, the best from year 9, the best from year 10, 11, and then 12. So what we're doing is we're choosing a few students from each of those layers according to our research need. Okay, we're not randomizing them. We're not putting all their names in a hat, all the students from year 7 in a box, and then we're not choosing them randomly. We're specifically having an agenda with which we are choosing the participants, okay? Now, obviously, the few students from each of those strata have now become our sample. So 5 students from year 7, 8, 9, 10, 11, 12, they basically become our total of 30 participants there. Okay, now that's just an example. Now, generally, we select participants in the same proportions that they exist in the population. This basically means if we've got 200 students to begin with in year 7, we've only got 100 in year 12, I'm naturally going to be choosing more participants from year 7 because the original number of participants or people in year 7 is bigger to begin with compared to year 12. Okay, so that's what we mean when we say we select participants in the same proportions or the same numbers as they exist in the actual population. Okay, so that's what stratified sampling is about. Random stratified sampling is the same thing, But rather than having an agenda with which we choose participants from each of those strata now, we are randomly selecting. So I divide my population again into year 7, 8, 9, 10, 11, 12. And from each of those groups now, I'm now randomly selecting. So from year 7, I take all the 100 or 200 names of the year 7 students, put them into a box, and the first 30 that I draw out from that will be my sample for year 7, and same for year 8, same for year 9, up to year 12. And that's a random selection because I'm randomly choosing the participants from each of the strata. I don't have an agenda. I'm not picking the best English students. I'm not picking the best math students. I'm not picking the best students who are good with problem solving. Okay, I'm just specifically randomly selecting. Okay, so random stratified sampling is like a combination of random sampling plus stratified sampling combined into one. Okay. The last sampling technique we're going through today, and the last topic I guess we're going through for today, is called convenience sampling. So convenience sampling is probably the easiest to understand. Convenience sampling is when maybe I'm running a research study and I'm just like, okay, I put out a little note in the newsletter, or I put out a little advertisement saying, okay, whoever wants to participate in this study, come ahead, go ahead and, come and sign your name and you can participate in my study. I'm not making any attempt to randomize the participants. I'm not making any attempt to match participants on certain variables. I'm just simply saying first come, first serve. If you want to be in my study, come, fill in your details, give me a call, give me a text, email me, and then you're in the study. Okay, so whenever you see a research scenario that says something about participants volunteering, that is an example of convenience sampling, because volunteering is always an example of convenience sampling where the person themselves or the participant themselves has volunteered to be in the study. Okay, so that basically is what convenience sampling is about. Convenience sampling is easy. It doesn't take a lot of time. It doesn't cost you a lot of money to do convenience sampling, but it does have one major problem in the sense that we cannot generalize results back to the population. And the reason we can't generalize results back to the population is that not every member in the population had an equal chance of being selected. Okay, only random sampling can achieve that equalization of participants, but convenience sampling can't do that. Okay, an example of that is if I'm running a study that's a really interesting study, and maybe maybe Lisa and Melanie saw the ad for my study early on, and they quickly joined up and they quickly signed up. But by the time Nikita could see my ad, all the places were already filled up. So even though Nikita wanted to be in the study, because she saw the ad a little too late, she wasn't able to sign up in time. So that's an example that not everyone has an equal chance of being selected for that study. Some people might miss out. So that's convenience sampling, selecting participants based on convenience, based on ease, based on how close they are to you. It's like if I was to conduct a study, I'd be likely to use you guys as my participants because I see you guys at least a few times a week. And, you guys are easy for me to have access to, okay, as compared to going out and finding another bunch of year 11s or year 12s. Okay, so the last topic I'm going to go through, just because it is connected to what we are doing, is random allocation. So last class, we went through experimental groups and control groups. We talked about the experimental group being the group that is exposed to the IV, and the control group is the group that's not exposed to the IV, right? So with the example of the red cordial and hyperactivity, the experimental group will be the kids who do drink the red cordial. The control group will be the kids who do not drink the red cordial or who drink something like neutral, like a glass of water instead. Random allocation is not random sampling, but random allocation is, okay, once the participants are in the study, once we've chosen our 30 or 40 participants who are going to be in the study, random allocation is allocating them to the experimental group or to the control group. And obviously, because we have the word random in this topic, random allocation is an allocation method where we are dividing participants to the experimental or control group, and each of those participants has an equal chance of being in the experimental group or the control group. So random sampling was for selecting our participants to be in the study in the first place. And random allocation is, okay, our participants are in the study now. Now we've got to allocate them or place them into their respective groups, whether that be the experimental group or the control group. Okay, so random allocation, we might use the same technique. So we've got 30 participants in the study. The first 15 names that I draw out of a box, they will automatically be my experimental group, and the remaining 15 names that are in that box are going to become my control group. And in this way, each person has an equal chance of now being selected to either be in the control group where they are exposed to the IV, or to be in the control group where they are not exposed to the IV, or where they are exposed to some inactive or fake treatment like the placebo. Okay, so that's basically what random allocation is about. Remember, allocation is how you divide something out. How you allocate something is how you divide something out. So random allocation is randomly dividing our participants into either the experimental group or the control group, where every participant has an equal chance of being selected for either group. And they can't just say, oh, actually, miss, I want to be in the control group, or I want to be in the control group, experimental group. That's not how it works. It has to be randomized, okay? So yeah, that's basically all we're covering for today. Any questions?